Assalam alikum. Today in this video we are going to learn something about O-levels chemistry. The topic name is titration and also some moles calculation inside it. But first we have to need to focus on what the titration is. We have to first of all see what titration explains us to us. There are two main points which I have just written that it is that to determine the concentration of different substances we do volumetric analysis, and to perform volumetric analysis we do titration. What is basically volumetric analysis and what is titration? We are just going to study it. Here I have diagram of that. I have the retard strength. It has a clamp with burette and it consists of a conical flask also. In this diagram we have different type of titrations. We have acid based titration, we have redox titration, and we have also sodium thiosulfate titration. But today we are just going to have some example of acid based titration. Acid base means the name coming from acid and base. We have two things. Now we have basically the alkali or base, you can say, in conical flask, but our main task is to find and calculate the concentration of the known volume. Although we have know the volume of base, or you can say that alkali in this conical flask, we can say that we have known volume. We have known volume. But we have to focus on the concentration of what this volume consists of. Let's suppose we have known volume of NaOH, which is 25.0 centimeter cube, but we don't know the concentration of this, so we are just going to have titration with this. In burette we have acid, you can say H2SO4, sulfuric acid. This acid has known concentration, and also when we are just going to perform the titration, and when the end point reaches, end point means the permanent color change of indicator which is added in this alkali in conical flask. The indicator could be methyl orange or phenolphthalein, it can be any which is mentioned in your O levels chemistry syllabus. Let's suppose we take the example of methyl orange. Methyl orange is basically the yellowish in base, but it comes to red or towards the orange color when the acid is in excess. But we have to reach at some end point that when we continuously stirring this conical flask, there would be a permanent color change in this. So to find the permanent color change, we have to just focus on the titrant. Titrant means the volume of sulfuric acid which is used to reach the end point of this titration, and this volume can be calculated when we just perform the titration and when the end point reaches. So we noted the volume of this H2SO4 sulfuric acid from this burette. We have also the known concentration of this sulfuric acid, and when we calculate the volume we just get our two things in our data, the volume and concentration. We have one formula which is known as number of moles equals to, you can say that, concentration into volume. When we just calculate the volume, which is the volume of titrant, means that sulfuric acid used in this titration, we put this volume here. There is known concentration, we have the known concentration of this sulfuric acid, we must put there, and we can easily find the moles of sulfuric acid due to this calculation. Now we have also the known volume of NaOH, which is 25 centimeter cube, but we don't have the known concentration. This titration is just performed, it is written in the first point to let or to know the concentration of this alkali or base. So for this I have the one question for you. I would write the question here and you will see the calculations which I just performed here and what the titration is basically all about it. First, I'm writing the question. Basically, titration is all about the story, all about the concept you are getting in volumetric analysis. So for this, we just have to solve one question for this. Now I'm just writing the question here. You would be finding the example of this and how to solve the titration calculations. You will be getting the answer soon. Now you can just relate this example which I'm just writing of this question to this scenario, and you will understand how the calculations of titration is done. Now we have to find the concentration of ammonia in the ammonia solution, which is usually used in our homes to clean the homes or to clean the floor of the homes. Find the concentration of ammonia in ammonia solution. Now, we have some data here. We have just written that a household ammonia was analyzed to determine its ammonia content. 25 centimeter cube of the ammonia solution required 21.9 centimeter cube of 0.11 mole per decimeter cube of sulfuric acid for endpoint. Here we have the just known volume of this. You just have to know this, that ammonia is basically the alkali or base. The alkali or base which is already present in conical flask is here. We have its known volume, but we have to find its concentration in gram per decimeter cube. Now, for this, we have just given the condition of it, just given the data for the sulfuric acid, which is 21.9 centimeter cube, the titrant value, and its concentration, which is also known. Now, first, after getting this data, we are just going to multiply this to get the moles required for this calculations, and the moles are 21.9 into 0.11. But do remember the 21.9 centimeter cube, and here is 0.11 mole per decimeter cube. As you know, the concentration is usually in mole per decimeter cube. So for this, we have to just divide this by 21.9 by 1000. Now we have to solve this. Now we have just got the moles of sulfuric acid, which is 2.409 into 10 to the power minus 3. You can say that exponential minus 3 of sulfuric acid, H2SO4. When you just write the equation of sulfuric acid and ammonia solution, you would be getting answer ammonia sulfate. So the moles ratio of sulfuric acid and ammonia would be seen like this. Now we know that ammonia is basically NH3 and sulfuric acid basically H2SO4. Now the product would be ammonium sulfate, so it would be NH4, and you know that the ammonium valency is +1, so this is sulfate valency is like this. So it would be getting 2 moles of this, and yes, it is balanced. So it means when we are just getting 2.409 exponential -3 moles of sulfuric acid, we are just getting into multiplied by 2. So we could just getting the moles of 4.818. 4.818 into 10 to the power -3, the moles of NH3. Now, our task is to find the concentration of ammonia in gram per decimeter cube. We have just find the moles in this. So for letting it to find into grams per decimeter cube, we just have to know that the volume which is required in the experiment for ammonia, the volume is basically 25 centimeter cube. But to convert these moles into grams, we have the formula of number of moles equals to mass in gram divided by molecular mass. So we are just going to multiply this answer with 17. As you know, the molecular mass of ammonia is 17. So the molecular mass, you can say the grams would be 0.08. It would be 0.0819 grams of ammonia. But the last thing you have to just know that the volume which is present should be in decimeter cube, as it is written that our concentration should be in gram per decimeter cube. So for converting this 25 centimeter cube to decimeter cube, you have to divide this by 1000. So our answer would be 0.819 divided by 29 and again divide by 1000. So our answer would be, it would be 3.28 gram per decimeter cube. This is the concentration of ammonia. That's it.